today we're going to be talking about proportions, but we're going to be talking about them in terms of like real world problems. So like we're going to do some word problems here. And so what we're going to do is we're going to take some situations that we might see in everyday life and see how we can use a proportion to help us figure something out about them. Before we do, just a quick refresher here. What's a ratio? We talked about this in the opener, so it should be nice and fresh now. Yes, exactly. So a ratio is a comparison of two numbers and more specifically, the way we're going to write our ratios is using a fraction. So ratio is a comparison of two numbers using a fraction. A ratio could simply just be a fraction, 2 over 3. That's a ratio. Another example of a ratio, though, would be something like 2 apples cost $3. How would you write that ratio? So 2 over 3, that's a ratio, right? But we could also add to that and say 2 apples cost $3. And it's still two numbers, right? But now each of those numbers has a meaning. Or if you think about the examples we were using when we did proportions before, we did some cooking examples where we're talking about the number of eggs it takes to make a number of cookies. So they're still numbers, but it's the number of eggs and the number of cookies you get out of it. All right, so what are these called here when we say how many of something we're using, whether it's apples or dollars or miles or inches or liters or whatever? What are all those called? You guys know? All of these things that we can use to describe what these numbers are units. So these apples are units, right? It says how many apples we have. The dollars are units. So what we're going to be dealing with these word problems is we're going to be dealing with a ratio of units. All right, so a ratio of units is no different than any other ratio, except it has what in it? It's a comparison of what? Now, a ratio is a comparison of numbers. So it's a comparison of units. Okay, so give me some examples of units. I just gave you a couple here. Apples, dollars. What's another one? Grams, inches, feet, miles, gallons. These are all units, right? So they're ways that we measure how much of something we have, right? So a ratio of units is just a comparison of units by using a what? What are we going to use to compare them? How do we compare the numbers with a ratio? What did we use? You just wrote it down. Fraction. Okay. Can anybody give me an example of a ratio of units that you hear about in everyday life? What does miles per gallon mean? Yeah, exactly. So miles per gallon is a ratio of units, and it tells us how many miles your car can go for every gallon of gas that it has. So this is actually a ratio of units, miles per gallon. Now notice that when I write that, this bar right here, the fraction bar, I read as per, right? Can you think of any other ones that are like that, like miles per gallon? So miles per hour, usually we write miles per hour like this, right? MPH. But if we were going to write that as a ratio of units, you could write it as miles over hours. So miles per hour is a ratio of units. So it tells us how many miles we can go in 1 hour. But if you go to the hardware store and you're going to buy like hardwood floor for your floor at home, it's going to be dollars per square foot, right? You ever heard that ratio? So dollars per square foot. Okay, so basically what dollars per square foot means is how much something is going to cost for every square foot. Okay, you might even hear that just for the cost of a house. How much it costs to buy a house is it's this much per square foot. Okay, so that's another ratio of units. So a ratio of units is just a ratio or a comparison of any two units. Does that make sense? If you go back to the cooking example that we did before, we could do eggs, the number of eggs that we need to make every cookie. That would be a ratio of units. All right, we're going to use these ratio of units to do some of these problems here. So this is a problem right here that has to do with proportions. We're going to use a proportion to solve it. And so what we have is a map. A map is not the same size as the state of Illinois, right? It's like the state of Illinois, but we shrunk it down so we can fit it in our hand, right? So in our map of Illinois, 3/4 of an inch represents 12 miles. It's approximately 9 inches from Belleville to Champaign on the map. What is the actual distance in miles? Forget about the numbers in this problem. The first thing when we're doing a word problem with proportions, we're always going to do first is write a ratio of units. Okay, so I want you to write that down right now. Just ratio, just like I'm writing it. Ratio of units. And for this problem, what are the two different types of units that we're using? Remember, the units don't have anything to do with the number. It's just what we measure it with. So the two units are what? Inches and miles. All right, so our ratio of units in this problem that we're going to use is going to be inches over miles. Now, I'll tell you from the very beginning, it doesn't matter if we put inches on top or if we put miles on top. We just need one of them on top and one of them on the bottom. Now, let me just clarify this real quick. When we're talking about inches, are we talking about inches in real life or inches on the map? Inches on the map, right? When we're talking about miles, are we talking about miles on the map or miles in real life? Miles in real life, right? So every inch in the map represents a certain number of miles in real life, right? Okay. So the next thing I'm going to do is I'm going to write a ratio that I know. So the ratio that I know, and I'm going to write this down here. This is what I know. Need a little bit more space here. So the ratio that I know is that 3/4 of an inch represents 12 miles. So should I put the 3/4 of an inch on top or the bottom for the part that I know? What do you think? Why on top? Malik says that the 3/4 should go on top. 3/4 of an inch. Why do the inches go on top? Mark?
You don't know how much miles you have to travel?
No, we do know the miles that are going to go with this. So why would the 3/4 go on top? Because when we wrote our ratio of units over here, we had inches on top, right? So we write this ratio of units so that we know which one goes where. So the 3/4 of an inch goes where the inches go. The 12 miles is going to go where the miles go. So the miles are going to go on the bottom. Okay, and then the part that we want to know, okay, or the part that we don't know yet, I'll just put a question mark there. That's going to be another ratio. We're going to know part of it, though. So it says it's approximately 9 inches from Belleville to Champaign. So in this ratio here, where is the 9 inches going to go? Top or bottom?
Top.
Top. I heard both answers. Top or bottom?
Top.
Why top? Because it's inches in the map, right? So remember, the top is always going to be inches. The bottom's always going to be miles. Do we know how many miles it is to Champaign? No. In fact, that's the question, right? What is the actual distance in miles? So since we don't know that, what could we put there? A variable, yeah. What variable you guys want to use? I'll let you pick. X, A, B. How about C? I like C. You know why? Because we want to know how far it is to Champaign. All right, so what do we have right here? What is that? That's a proportion, right? So we set up a proportion using a ratio of units with one ratio that we know and another ratio that we only knew part of with a variable in it. Now what can we do with this? Cross, multiply, and solve, right? Don't you guys love the fraction on this one? Well, it's not so bad, right? What's 3/4 times C? 3/4 C, okay. Let's see how we handle this fraction here. So we get 3/4 C times, or not times, equals 12 times 9, which is 108. So then I need to get that c by itself. We have 3/4 times c. What do I do to get rid of the 3/4? Divide by 3/4, right? So if I divide by 3/4, that's the same thing as doing what? When we divide a fraction, what do? See if you remember. What's your favorite chicken place? How about KFC? You remember KFC? Yeah?
No.
You remember KFC? Keep, flip, change. So we keep the 108, we flip the 3/4, we change the division to multiplication. So when you divide by a fraction, you keep the first one, you flip the second one, and then you change the division to multiplication. An easy way to do this, you can multiply 108 times 4 in your calculator and divide by 3. So just type in 108 times 4 divided by 3. 144. One more really important part of this problem. That 144 is answering a question, and we need to be sure that we answer the question correctly. So is our answer here 144 inches, or is it 144 miles?
144 miles.
Okay, so the full answer to the question it would be, if you were going to say this in a full sentence, how would you answer that question? The question says, what is the actual distance in miles to Champaign? How would you answer that? So it is 144 miles from Belleville to Champaign. You're not going to have to write out your answers like that in a full sentence, but you should always have units on your answer. And the units are really easy because since we're solving for C, we know C is miles because it's on the bottom, right? So you can always look at your ratio of units over here and see what the units are supposed to be. So when we're doing these word problems, you should always have units on your answer. Don't forget that. All right, let's look at another one. Probably should have started with this one. This one's an easier one. All right, so on average, a particular basketball player makes 7 out of every 9 free throws she takes. If she shoots 216 free throws during the season, how many of those would you expect her to make during the season? Okay, so she tries to shoot 216 of them. Is she going to make all 216 of them? No, she's only making 7 out of every 9, right? So she's not going to make all of these. We want to know how many out of these 216 she makes. What's the first thing we do on this type of problem? What's the first thing we did on the last one?
Ratio.
We're going to write a ratio of units. All right, so I'm gonna write that on every one of these. Ratio of units. So for this particular problem, we're going to have 2 different units going on here. What are they? Free throws and free throws? Ooh. Do we have 2 different units here? So she made 7 free throws out of every 9 free throws she takes. So how do I distinguish between the 7 and the 9? What units would I put with the 7, do you think? Okay, or we could say baskets or baskets made, right? So I'm just going to put made free throws.
And missed.
Well, is it going to be missed though? So did she miss 9 free throws?
No.
She missed 7 out of the 9.
She made 7 out of the 9. So she only misses 2 out of 9, but that 2 doesn't really help us because I want to keep the 9 that she took here, right? So what could I put for the units on the 9? How about free throws attempted? I like that. Here, let me do it this way. So attempted, the ATT stands for attempted. So attempted free throws. So that's just how many she tried to shoot, right? So the made free throws, we're going to put on top, the attempted free throws on the bottom. Could I put it the other way?
No.
You could. This one actually kind of tells us the way it's usually written here. 7 out of 9 means that 7's probably going to go on top and 9's going to go on the bottom. You would still get the right answer if you flipped it, though. If you put the 9 on top and the 7 on the bottom, as long as you flip everything. All right, so there's your ratio of units. So now let's make a ratio of what we know. So the one we know is when she makes 7 out of every 9. So does the 7 go on top or does the 7 go on the bottom? 7 goes on top. Why? Yeah, that's how many she makes, right? She makes 7. And what goes on the bottom? 9, because that's how many she takes, right? Or attempted. So 7 made free throws for every 9 attempted. And then the part that we want to know, okay, so we know part of it, right? We have 216 free throws. Is this made free throws or is it attempted free throws? It's attempted, right? So where does that 216 go? That goes on the bottom, exactly. All right, so this ratio of units is really helpful because we can just see, well, we know these are attempted free throws, so that's going to go on the bottom. All right, now we need a variable here for the top. Let's make a variable that makes sense.
Oh,
What'd you say?
A.
A? What does A stand for? What do you think, Trey? S? What does S stand for? Season? Okay, so the number she makes for the season. All right, cool. So we have a proportion, right? Notice that all I did here is put the equal sign between the ratio that I know and the ratio I don't know. And so how do I solve for S? Cross multiply. 9 times S is 9S. 7 times 216 is?
1,512.
Okay, 1,512. And then how do I get S by itself? Divide by 9 on both sides. So we get S all by itself over there, 168. Okay, remember this is really important. 168 by itself doesn't mean anything. We need to be sure we answer the question. So what is the 168? Is that how many free throws she took?
How many she made?
Yeah, that's how many she made. So we're going to say 168 made free throws.
Okay, I got a question. So I know math worksheet on this, right?
Mm-hmm.
If we're gonna get points taken off, if we don't tell us.
So there are a few things in these problems that we're going to be looking for. First of all, you need to write a ratio of units for every one of these problems. It'll help you, I promise, so don't worry about it. So you're going to write a ratio of units, then you're going to write a ratio that you know, and another ratio where you only know half of it. So you've got a proportion. You solve the proportion and get your answer, and then you need to include the units. All of that stuff is necessary for the solution of these. All right, now, the last one actually is 2 parts. So you guys have heard of the Indy 500, right?
Yeah.
It's a race where they drive around a track for hours, just driving in circles. It's really exciting. And so they drive 500 miles on the track. And so the track record is this guy in 1990, R.E. Lewandijk. It took him 5 minutes to drive 13.442 miles. That's really fast, by the way. We'll figure out exactly how fast in a second, but he can drive 13.442 miles every 5 minutes. We want to know, for the first part, how many miles can he travel in 1 hour? All right, so let's start just like we do every other problem. We don't even really need to think about much right now because we know we're going to have to do this, right? So what's our ratio of units going to be? What 2 units are we using in this problem? Okay, I see miles and minutes, right? So those are going to be the 2 units that we're going to use, the miles and minutes. Do you guys care which one goes on top?
No. Yeah. No.
Okay, we'll put miles on top and we'll put minutes on bottom. Just like the other ones, it really doesn't matter which one goes on top and which one goes on the bottom. You'll still get the right answer as long as you put things in the right place. All right, so the ratio that I know, how many miles can he go in how many minutes?
5 minutes.
Okay, 5 minutes. So does that go on top or bottom, Levante?
The bottom.
Okay, the 5 minutes is going to go on the bottom. And what goes on top?
500.
No.
I said miles.
How far does he go? How many miles can he go in those 5
Oh,
minutes?
13.4.
13.442. Okay, so 13.442 miles over 5 minutes. That's the ratio that we know. How about the ratio that we don't know the whole thing? What's the question here? At that rate, how many miles could he travel in 1 hour? So in this question, do we know how many minutes he's going or how many miles he's going?
Miles.
How many miles is he going?
13. No,
No.
5 miles.
Look at the question, guys. It says how many miles. Do we know how many miles?
No.
No, that's what we're trying to figure out, right? Do we know how many minutes?
Yes.
How many? 1 minute?
Wow.
60 minutes. Thanks, Mark. So it says how many can he travel in 1 hour? So we know how much time it takes. We just don't know it in minutes yet. But how many minutes are in an hour? 60. All right, so you have to be careful on these. You look at the question. We want to know how many miles he can go. So that's going to be our question or our variable. And then in the amount of time is going to be 1 hour, which is 60 minutes. So our 60 is going to go on top or bottom? Bottom, because our minutes are on the bottom, right? How about on top? What variable you want to use? I'm gonna use D. You know why D? It's gonna be the distance that he travels in that time. All right, so how do I solve this? You guys know how to solve this, right? What do we do? Cross multiply. 5 times D, 5D, 13.442 times 60. I don't know what that is. Use your calculator.
806.52.
806.52? Okay, you guys agree with Levante? Okay. And then to get the D by itself, divide by 5. Yep, do it on both sides, and we get D all by itself, right? Equals. Okay, did it say to round here? No, it didn't say round. We get it stops after the 0.304, so let's just leave that on there. We might as well. So we get 161.304. What is that? What are our units for that? Miles, right? So it's actually, it just says how many miles could he travel, right? So that's our answer, 161.304 miles. Now let me ask you something. How fast is he going? How long has it taken him to do that?
5 minutes.
No.
Oh, 60 minutes.
60 minutes, 1 hour, right? That's 161 miles per hour. It's pretty fast. Anybody in here driven 161 miles per hour before? No, me neither. And he's averaging that over the course of the whole race. It's pretty impressive, I think. Anyway, so then the second part says, how long would it take him to drive 500 miles? That would be the whole race, right? Okay, so for the second one, for part B, what ratio that we used here is going to stay the same, and which one's going to change?
5 minutes gonna stay the same.
The 5 minutes is going to stay the same. What else is going to stay the same?
60 minutes.
Nope. It's not going to be 60 minutes anymore because the race is going to take him longer, right?
Right.
Okay, it takes him it takes him an hour to drive 161 miles, but he has to go 500 miles. So it's not going to take an hour. It's going to be more than an hour, right? So the 5 minutes is going to stay the same. It still takes him 13.442 miles every minute or every 5 minutes, right? Okay. So yeah, so this ratio right here is going to stay the same. So my ratio of units stays the same. It's still miles over minutes.
You forget about the ratio.
It's still going to be 13.442 miles for every 5 minutes. And so then what we need to figure out is what part do we know and what part do we need to know for this other ratio?
How long are you driven?
How many minutes it took him?
Okay, we need to know how many minutes, right? So it says how long would it take him. So we want to know a number of minutes. I'm going to use T. You know what T stands for? Time. All right, so what do I put on top then? 500 miles, right? We want to know how long it takes him to drive 500 miles, so we put the 500 where the miles go. Then what?
We multiply.
Cross multiply and solve. Now, I will tell you on this one, you're going to have to round. Let's round to the nearest minute. So we should get 2,500 divided by 13.442. Type that into your calculator and round it to the nearest minute. What do you get? The nearest whole number.
185.
Okay, so we get 185.9 something, right? And if we're going to round to the nearest minute, we're going to round that 5, so that 9 is going to make it go up to a 6. So it takes about 186 minutes for him to drive all 500 miles. Anybody know about how long that is?
That's 1 hour, 3 hours.
Yeah, it's a little over 3 hours, right? So 1 hour is 60 minutes. 3 hours would be 180 minutes. So it's just over 3 hours that it takes him to finish the race.